Arc fault protection offers several benefits, particularly in older homes. A primary benefit is the reduced risk of electrical fires. Arc fault circuit interrupters, or AFCIs, are designed to detect and interrupt potentially dangerous electrical arcs that can ignite fires. By quickly isolating the problem, AFCIs minimize the duration of exposure to arcing, consequently reducing the likelihood of a fire starting. In essence, AFCIs add an extra layer of protection against electrical fires, especially in areas where traditional circuit breakers may not be sufficient. They offer peace of mind by proactively detecting and addressing potential hazards. Older homes typically have outdated electrical systems that may not meet current safety standards. Replacing existing breakers with AFCIs can significantly improve the safety of these homes by mitigating the risk of fires caused by aging wires, loose connections, or damaged insulation. Regarding the specific protection expected from replacing breakers with AFCIs in older homes, there are several key areas to consider. Firstly, there is the detection of series arcs. Series arcs occur when the electrical current jumps across a gap in a conductor, resulting in a continuous arc that can cause overheating and fires. AFCIs are specifically designed to detect and interrupt these series arcs, preventing them from escalating into a dangerous situation. Secondly, AFCIs provide mitigation of parallel arcs. Parallel arcs occur when electrical current flows along the surface of a conductor, creating excessive heat that can damage the insulation. While traditional circuit breakers may not detect parallel arcs, AFCIs can sense the abnormal current pattern and trip to prevent overheating. Thirdly, AFCIs offer protection against loose connections. Loose connections can create arcing conditions that increase the risk of fire. AFCIs can detect the increased resistance caused by loose connections and trip to prevent arcing and potential fires. It is important to note that AFCIs are not always required in older homes, but they provide a significant level of protection against electrical fires. The decision of whether or not to install AFCIs in an older home should be made by a qualified electrician after evaluating the specific electrical system. The installation of AFCIs involves replacing existing circuit breakers in the electrical panel with AFCI breakers. These AFCI breakers are designed to monitor the electrical current for characteristics that indicate the presence of an arc fault. When an arc fault is detected, the AFCI breaker trips, interrupting the flow of electricity and preventing a potential fire. There are two main types of AFCIs: branch/feeder AFCIs and combination AFCIs. Branch/feeder AFCIs provide protection against series arcs and parallel arcs in the branch circuit wiring. Combination AFCIs provide the same protection as branch/feeder AFCIs, but also offer enhanced protection against series arcs in cord sets and power supply cords. When choosing AFCIs for an older home, it is important to select the appropriate type based on the specific needs of the electrical system. A qualified electrician can help determine which type of AFCI is best suited for a particular application. In addition to providing protection against arc faults, AFCIs also offer protection against overload and short-circuit conditions similar to traditional circuit breakers. This means that AFCIs can protect against a wide range of electrical hazards, making them a valuable addition to any electrical system. However, it is important to understand the limitations of AFCIs. AFCIs are not designed to protect against shock hazards. Ground fault circuit interrupters, or GFCIs, are used to protect against shock hazards. GFCIs are typically installed in areas where there is a high risk of contact with water, such as bathrooms, kitchens, and outdoor outlets. It is also important to note that AFCIs can sometimes nuisance trip, meaning that they trip when there is no actual arc fault present. This can be caused by electrical noise or other factors. If an AFCI nuisance trips frequently, it may be necessary to investigate the electrical system to determine the cause of the problem. The National Electrical Code, or NEC, provides requirements for the installation of AFCIs in new construction and existing homes. The NEC requires AFCIs to be installed in all branch circuits that supply outlets in dwelling units, with some exceptions. The NEC also provides requirements for the testing of AFCIs. AFCIs should be tested monthly to ensure that they are functioning properly. To test an AFCI, press the test button on the breaker. The breaker should trip, interrupting the flow of electricity. If the breaker does not trip, it may be defective and should be replaced. The cost of installing AFCIs can vary depending on the number of circuits that need to be protected and the complexity of the electrical system. However, the cost of AFCIs is typically less than the cost of repairing the damage caused by an electrical fire. In addition to installing AFCIs, there are other steps that can be taken to improve the electrical safety of an older home. These steps include having the electrical system inspected by a qualified electrician, replacing any damaged or outdated wiring, and installing smoke detectors and carbon monoxide detectors. Regular electrical inspections can help identify potential hazards before they cause a problem. A qualified electrician can inspect the wiring, outlets, and other electrical components to ensure that they are in good condition and meet current safety standards. Damaged or outdated wiring can increase the risk of electrical fires. Replacing this wiring can significantly improve the safety of the home. Smoke detectors and carbon monoxide detectors can provide early warning of a fire or carbon monoxide leak. These detectors should be installed on every level of the home and tested regularly. In summary, arc fault circuit interrupters offer a significant level of protection against electrical fires, particularly in older homes. By detecting and interrupting dangerous electrical arcs, AFCIs can prevent fires from starting and protect occupants from harm. While AFCIs are not always required in older homes, they are a valuable addition to any electrical system. A qualified electrician can help determine whether or not AFCIs are appropriate for a particular home and can install them properly. Furthermore, it's crucial to understand that AFCIs are designed to detect specific types of electrical faults, primarily those related to arcing. They are not a substitute for proper wiring practices, regular electrical inspections, and other essential safety measures. For instance, while AFCIs can detect loose connections that lead to arcing, they cannot prevent all problems caused by faulty wiring. Similarly, they do not protect against electrical shock. That's the role of ground fault circuit interrupters. It's also essential to consider the specific electrical characteristics of the older home when installing AFCIs. Older homes may have wiring systems that are more susceptible to voltage fluctuations, grounding issues, and other electrical anomalies. These factors can sometimes lead to nuisance tripping of AFCIs, where the breaker trips even when there is no actual arc fault. In such cases, it may be necessary to troubleshoot the electrical system to identify and correct the underlying issues. This might involve checking for loose connections, replacing faulty outlets or switches, or upgrading the wiring system. Another important aspect to consider is the compatibility of AFCIs with other electrical devices and systems in the home. Some older appliances and electronic devices may generate electrical noise or harmonics that can interfere with the operation of AFCIs, causing them to trip unnecessarily. In these situations, it may be necessary to install filters or other devices to mitigate the interference. It is also worth noting that AFCIs are subject to specific installation requirements under the National Electrical Code. These requirements cover topics such as the location of AFCIs, the types of circuits that require AFCI protection, and the methods for testing AFCIs after installation. It is essential to comply with these requirements to ensure that the AFCIs function properly and provide the intended level of protection. When selecting AFCIs for an older home, it is important to choose products that are specifically designed for residential applications and that meet the latest safety standards. Look for AFCIs that are listed by a recognized testing laboratory such as Underwriters Laboratories or Intertek, and that have been tested and certified to meet the requirements of UL 1699, the standard for arc fault circuit interrupters. In addition to providing protection against electrical fires, AFCIs can also help to reduce the risk of electrical shock. While AFCIs are not specifically designed to protect against shock hazards, they can sometimes trip in response to ground faults, which can cause electrical shock. However, it is important to remember that AFCIs are the primary means of protection against electrical shock, and they should be installed in all areas where there is a high risk of contact with water. Furthermore, consider the long-term maintenance and upkeep of AFCIs. Like any electrical device, AFCIs can degrade over time due to factors such as age, exposure to heat and humidity, and electrical stress. It is recommended to test AFCIs periodically, typically once a month, to ensure that they are functioning properly. If an AFCI fails to trip when tested, it should be replaced immediately. In addition to testing, it is also important to visually inspect AFCIs on a regular basis for signs of damage or wear. Look for cracks, discoloration, or other signs of deterioration. If any damage is detected, the AFCI should be replaced. When replacing AFCIs, it is important to use the correct type and rating for the circuit being protected. The AFCI should have the same voltage and current rating as the existing circuit breaker. It should also be of the same type, either branch/feeder AFCI or combination AFCI. It is also important to follow the manufacturer's instructions when installing or replacing AFCIs. The instructions will provide detailed information on how to properly install and test the AFCI. In addition to the technical aspects of AFCIs, it is also important to consider the human factors involved in their use. Homeowners should be educated about the benefits of AFCIs and how to test them. They should also be instructed on what to do if an AFCI trips frequently or if they suspect that there is an electrical problem. It is also important to ensure that homeowners have access to a qualified electrician who can provide assistance with any electrical issues. The electrician should be able to troubleshoot electrical problems, install AFCIs, and provide other electrical services. In conclusion, arc fault circuit interrupters are a valuable tool for improving the electrical safety of older homes. They can help to prevent electrical fires, reduce the risk of electrical shock, and protect occupants from harm. However, it is important to understand the limitations of AFCIs and to use them in conjunction with other safety measures such as regular electrical inspections, proper wiring practices, and the installation of smoke detectors and carbon monoxide detectors. It is also important to consult with a qualified electrician to ensure that AFCIs are properly installed and maintained. By taking these steps, homeowners can help to ensure the safety of their homes and families. Moreover, the integration of smart home technology with AFCIs presents new possibilities for enhanced electrical safety. Smart AFCIs can provide real-time monitoring of electrical circuits, detect potential problems before they escalate, and send alerts to homeowners or electricians. These smart devices can also be integrated with other smart home systems such as security systems and lighting controls to provide a comprehensive safety solution. For example, a smart AFCI could be programmed to automatically shut off the power to a circuit if a potential arc fault is detected, and then send an alert to the homeowner's smartphone. Similarly, the AFCI could be integrated with the home's lighting system to automatically turn on the lights in the event of a power outage. The development of smart AFCIs is still in its early stages, but these devices have the potential to revolutionize electrical safety and provide homeowners with greater peace of mind. As smart home technology becomes more prevalent, it is likely that AFCIs will become an increasingly important part of the home safety infrastructure. In addition to smart AFCIs, there are other emerging technologies that could further enhance electrical safety in older homes. For example, arc fault detection devices that can be installed directly on appliances or electrical equipment could provide more localized protection against arc faults. These devices could be particularly useful in older homes where the wiring system is more susceptible to arc faults. Another promising technology is the use of non-invasive sensors to detect electrical problems. These sensors can be used to monitor the condition of wiring, outlets, and other electrical components without having to physically inspect them. This could allow for early detection of potential problems before they cause a fire or other safety hazard. As these and other emerging technologies continue to develop, they are likely to play an increasingly important role in improving the electrical safety of older homes. Furthermore, the ongoing research and development efforts in the field of electrical safety are constantly leading to new and improved AFCIs and other safety devices. These advancements are driven by a desire to reduce the risk of electrical fires and protect people from harm. As new technologies and safety standards emerge, it is important for homeowners and electricians to stay informed and adopt the latest best practices. This will help to ensure that older homes are as safe as possible. Finally, remember that electrical safety is a shared responsibility. Homeowners, electricians, and manufacturers all have a role to play in ensuring that electrical systems are safe and reliable. By working together, we can reduce the risk of electrical fires and protect people from harm. By considering these points, one can better understand the broader context of arc fault protection and its importance in maintaining electrical safety, especially in older homes.